Okay, this is parametric equations and calculus. May sound strange taking a laptop hiking, but one of the things I do on the side, I have to be online um, for questions via Zoom. They pay me really good money, and so versus getting in trouble with that job, and that's probably provides 50,000 extra a year. I thought, it's worthwhile. I actually rented a motel room since we were going to go out and camp and a tent and so forth. But I thought I'm going to have someplace I can go and check email so I don't get in trouble with this place. Even though I got online uh, 3 of the nights before we went, just to kind of cover myself. I thought, sure enough, I don't get on, somebody's going to fail a test and scream, and then I'll be in bad shape. So I rented a motel room, and just for answering emails. And it's interesting because it was out at Scott City. Anybody know where that's at? No. Jerusalem Badlands is out there. It's kind of a little cool little place for Kansas. And we were going to hike at or camp at the lake there. And the place that my stepson reserved was horrible. There was really no place to put a tent. There was only one place that was even feasible, and they had these little fire ants. I mean, there must have been hundreds of them just crawling back and forth, and so it turned out that we used the motel room anyway. We still did a lot of hiking, but yeah, strange experience. Okay, parametric equations and calculus. Parametric form of the derivative. If a smooth curve C is given by the equations x equals f of t, y is equal to g of t, then the slope of C at x, the point xy, is dy dx equals dy dt over dx dt, where dx dt is not equal to 0. So on top, you take the derivative of y with respect to t. On the bottom, you take the derivative of x with respect to t. Very simple formula. Let's look at number 5. And instructions find derivative of y with respect to x, dy dx. So for my formula, on top, we're going to take the derivative of y with respect to t. So that gives us negative 6. On the bottom, we'll take the derivative of x with respect to t, dx dt. So that gives us 2t, which simplifies to negative 3 over t. Okay, same instructions. We got x equals sine squared, y is equal to cosine squared. Doesn't matter that they're not t's, if they're theta, it's still the same principle. So dy dx. I'm going to take the derivative of y with respect to theta up on top. This is parentheses to a power, so this would be what rule? Chain rule? Yeah. So take your power, put it out in front. What's inside your parentheses remains as is. Lower your power by 1 times the derivative of what's inside. And derivative of cosine is negative sine. And then on the bottom, you're going to take the derivative of x with respect to theta. And again, this is a chain rule. Parentheses to a power. So you take your power, put it out in front. What's inside remains as is. Lower your power by 1 times the derivative of what's inside the parentheses, which is cosine. Cosines cancel, sines cancel, 2's cancel, and I'm left with -1. Yeah, I wore my steps on hiking. In the afternoon, I failed miserably. So I got very little endurance, I guess. I could go for a short period of time. He was just dying. Oh, probably 2 or 3 miles. Not a big thing total. But then in the afternoon, I think I'm chicken. I started heading up the side of a hill, and I got looking down, and I envisioned myself rolling down through the cactus, and I got about halfway up the hill, and I gave it up. So I think that was the last of my hiking, actually. Now we have some formulas for second derivative and third derivative. Now, to find your second derivative, you take the derivative of the first derivative, which, here's the formulas we want. You find your dy dx, and that'll be in terms of t, and you take the derivative of that with respect to t. That goes on top. And then on the bottom, you put dx dt. So you take the derivative of x with respect to t. Now our third derivative, ignore this middle one. Coming over here, you take the derivative of your second derivative with respect to t on top. And over in the bottom, it's dx dt again. So not hard formulas to use. No. Once you get the first derivative, you take derivative of it, and it goes up on top. And then always on the bottom is a dx dt in all forms. Okay. This wants us to find dy dx, and then our second derivative, find the slope and concavity, if possible at the given value of the parameter. I guess dy dx would be back here. So remember, this is the derivative of y with respect to t over the derivative of x with respect to t. So derivative of y with respect to t is 3, derivative of x with respect to t is 4. For our second derivative, we're going to take the derivative with respect to t of dy dx. On the bottom, we'll have our dx dt again. So this is the derivative with respect to t of 3/4 over dx dt. And derivative of 3/4 is 0. Dx dt doesn't change, it's 4. So that gives us 0. Now, the first thing they're asking us for, after we find those, is find the slope. Remember, slope comes from your first derivative, doesn't it? There is no t to plug it into. So at t equals 3, m is going to equal to 3/4. Remember concavity? What a positive number indicate to you? Concave up. What's a negative number? Concave down. So 0, no concavity, right? So not all of those would be our answers.
Can you explain how you did that second derivative?
You from our formula, you take the derivative with respect to t of your first derivative. So my first derivative was 3/4. So I took the derivative with respect to t of 3/4. Yeah. Derivative of a number is just 0. Let's take a look at this one. X is equal to t plus 1. Y is equal to t squared plus 3t. And we're interested in t is equal to -2. Same instructions. Find first and second derivatives. Find the slope, concavity if possible, at a given value of the parameter. So dy dx, take the derivative of y with respect to t over the derivative of x with respect to t. Derivative of y with respect to t is 2t plus 3. Derivative of x with respect to t is 1. So that gives us 2t plus 3. Now remember, the first derivative gives us our slope, doesn't it? So we'll plug our -2 in. 2 times -2 plus 3. 2 times -2 is -4, plus 3 is -1. Now our second derivative. We take the derivative of our first derivative with respect to t over dx dt. So our first derivative is 2t plus 3. and dx dt is 1. So 2t plus 3 is 2. 2 over 1 gives us 2. At t is equal to -2. It's there's no t to plug it into, is there? So positive means it's what? Concave up. This one looked a little bit more interesting. So let's take a look at it. Number 17. X is equal to cosine theta to the third power. Y is equal to sine theta to the third power. Same instructions. Find dy dx, our second derivative, slope, concavity for the parameter. So we're going to take the derivative of y with respect to theta over the derivative of x with respect to theta. Again, chain rule. Take your power, put it out in front, lower your power by 1 times the derivative of what's inside, which is cosine. Derivative of x with respect to theta. Take your power, put it out in front, lower your power by 1 times the derivative of what's inside the parentheses, which would be a negative sine. Threes would cancel. I'm left with a negative. Sine and, well, sine squared and the sine here cancel a little bit. So that gives me a negative sine theta on top and cosine theta on the bottom, which gives me negative tangent. At theta is equal to pi over 4, now tangent is y over x. And at pi over 4, they're both square root 2 over 2. So that'd give me a negative 1 for my m. So then, for my second derivative, on top, we'll take the derivative of the first derivative with respect to t. And then the bottom will be dx dt. Theta, yeah. Okay, so up on top, we got negative tangent theta. Derivative of tangent is secant squared. And then on the bottom, the dx d theta we already have up here. So it's 3 cosine squared times negative sine theta. Gives us -1, actually gives us +1. We've got a negative here and we got a negative here. So those cancel. The sine squared can go down below as cosine squared. So I'm going to have 1 over 3 cosine to the 4th power theta sine theta. I could go through a lot of work on this. Well, negative here, negative here. I could go through a lot of work on this, find the exact value. But at pi over 4, we already said both of them are equal positive square root 2 over 2, aren't they? So if I put a positive square root 2 over 2 in there, if I put a positive square root 2 over 2 in there, it's going to give me a positive, won't it? Which means it's concave up. So concave up at theta is equal to pi over 4. Remember, that's all we really did with concavity. We would do intervals of concavity back in Calc 1, but we just cared about if it's positive or negative. The value really didn't matter. That's probably not a bad place for a 5-minute break. So we're about halfway through that section.